On 6A, we're talking about characterizing data. The distribution of a variable refers to a way its values are spread over all possible values. We can display distribution with a table or a graph. And this first thing that it is showing says find the mean or the average of the number of movies, the original and sequels or prequels for the 5 most popular science fiction movies. So they've got these 5 movies here. Most of I guess the most common measure of central tendency, which we're talking about mean, median, mode, and range, all those things. Most of the time, the thing that you're most familiar with is the mean because it's the average, which is not always the best thing to do. We'll talk about why in just a minute, but when we're talking about this, most people relate this to grades, right? If you want to find your average, you usually add all your grades up, divide by how many there are, depending on if your teacher has weighted them or not. But especially in high school and all that stuff, that's how you would find it. So we've got these. It says the mean is what we most commonly call the average or the sum. It is defined as follows. You would add up all the values and then you want to divide it by the total number of values. So in this problem up here, if we wanted to find the mean of this, okay, we would have to do 6 plus 8 plus 13 plus 8 plus 5, and we would divide that by 5 because there's 5 different movies. Okay, one of the most common mistakes people make is they go to their calculator and they type 6 plus 8 plus 13 plus 8 plus 5 divided by 5, and they're going to get the wrong answer because of what? Anybody know? What's getting divided by 5? This 5 right here is the only thing that's getting divided by 5 if you do it this way. Okay, so it's really better to find the answer to the top. So add the 6 plus the 8 plus the 13 and all that stuff. Okay, and get the answer to that, which is 40. Then do divided by 5, which is going to give you a mean of 8. Okay, and this is number of movies in the series. So these are the 5 most popular science fiction film franchises, and 8 is the average number of movies in that series. Okay, so that's the mean. The median is the middle value in the sorted data set, so halfway in between the values. So in order to find the mean, you have to put all the numbers in order, and we'll do that in just a minute, and you want to find the one in the middle. Sometimes there's more than one in the middle, but that's the goal, is to find the one in the middle. In this thing right here, right? Well, if I put these numbers in order from least to greatest, right? It looks like 5 is the smallest one. Then we've got 6, and we've got 2 8s and a 13. If I put them in order from the least to the greatest, right, this number right here is going to be the one in the middle, and that would be my median. And in this case, the median and the mean happen to be the same thing, but that doesn't always happen, right? Okay. So the mode is going to be the number that is listed the most often, and you can have more than one mode, but in this category things we were talking about up here, the mode would be 8 because that's the only one that's listed twice. Sometimes you don't have a mode if you don't, and we'll look at some examples of things like that. But if all of the numbers had been different, I would have put no mode. Okay. If I had 2 5s and 2 8s, I would have had 2 modes. I would have put 5 and 8. Okay, so and in the next class, I'm going to show you how you can type this list in the graphing calculator, and it'll spit these numbers out for you. If you're like me, when you're typing things in the calculator, sometimes, in fact, I did this morning really early. When I go to type this, so we're supposed to find the mean, median, and mode of these numbers right here. And these are on those notes I just gave y'all, right? This is the second page of them. Just making sure you've got it. So these are, when I go to type these in the calculator, inevitably, especially if it's a long list, I'm going to type something in wrong. So I will post that video on Friday of how to find it on the graphing calculator. But we need to at least know what we're talking about at first before we go there. So if I want to find the mean of this list, I'm going to add them all up, right? Type all this in the calculator. What am I going to need to divide by? Okay, yes, because there's 8 numbers here, so we would divide by 8. It's really smart if you're doing this by hand to total up the top, before you hit divided by 8, or so that you make sure that you're really dividing the whole thing by 8, not just this last number. So $11.28 divided by 8 gets me $1.41. Okay, so that's the mean, $1.41. Okay, if I wanted, the mode is really easy to talk about. The mode is the one that's listed the most, and these are already put in order for me. And the only thing I see 2 of is $1.29. So $1.29 is going to be the one that would be listed the most here. That's my mode. My median, in order to do this, actually, I don't know about that. In order to get the median, we need to put them all in order, right? This one just happens to already be in order from the smallest number to the largest number. And you start picking one off from the front and from the back to try to find the one that's in the middle. Well, on this problem, there's actually 2 numbers that are in the middle. Okay, if we only had one number in the middle, it would be the median. But since we have 2 numbers in the middle, to calculate it, we're going to need to add 135. So basically, we're finding the average of these 2 numbers, and 135 plus 139 divided by 2, which halfway in between those, you can imagine that that's $1.37. So that's our median. And the number in the middle is our median. Questions about how to find any of those? There's some data sets where it's just not even smart to talk about one or the other. This one, there's no, we talked about before how you could have an outlier and that number's way away from the data set. This one doesn't really have an outlier. Our $1.37 and our 141 and our $1.29 are actually kind of close together. So we could use any one of those to talk about this. I would think the mode is probably the most inappropriate one because both of those numbers are way below the other numbers. Okay, but there are ways that we describe our data. So an outlier is a data set. In a data set is a data value that is much higher or much lower than almost all other values. An outlier can change the mean of the data, but generally does not affect the median or the mode. So we've got 5 graduating seniors on a men's college basketball team. They received their following first-year contract offers to play in the National Basketball, or NBA, the National Basketball Association. 0 indicates that the player did not receive a contract offer. So the mean of this, so it looks like we got 4 of the players that didn't get an offer. So they're getting $0. But then we got 1 that would definitely be an outlier that's getting $10 million. Outlier in this group. That data set is way far from everybody else's. When I divide by 5, I would get $2 million. That would be my mean. Right? Not really a good way to talk about this data set because it doesn't really represent what's going on. In fact, right, 4 of them didn't get anything. So the mean would not be a good way to talk about this. That outlier did affect the mean though. What would be the median on this one? So if we're looking at numbers in the middle, right? 0. Actually, the median is not a bad way to talk about this because that's what happened to most people. They didn't get a contract. The mode would also be 0 because 0 is what's listed the most, right? So you kind of have to look at your data set to determine what is the best thing for this data set. And that second project has a lot to do with this stuff. Okay, so when we're looking at mean, median, and mode, okay, the mean is the sum of all values divided by the total number of values. Okay. Most people are very familiar with the mean, but most of the time people, when they talk about it, they'll say, what is the average? They won't call it the mean, but they'll say, what's the average? Okay, if you've got a set of data, your mean always exists. You can always find it if you've got a numbered list of data. Does it take into account every value? Yes. Okay, it's not like the median where you're crossing things off both sides. It's going to take into account every data set, even the outliers, right? Is it affected by the outliers? Yes, because we're adding up every number and dividing it by how many there are. Okay, some advantages are that it is commonly understood. So if you want to talk to somebody about your data, they'll kind of understand what the average is. And it works with many statistical methods. Okay. And most people have heard of the mean, they just refer to it as the average. It includes all the data set, right? The median is the middle value. Okay. And I'm going to put of an ordered data set because we really need to go from the smallest to the largest. You have to put them in order. You don't just look at a data set that's out of order and pick the one that's in the middle. That's not going to work. Okay, it's very common that somebody would talk about the median. As long as you've got a list of numbers, it always exists. You can find the median. Okay, does it take every value into account? No, right? Because the only thing it takes into account is what's the number in the middle, right? So it doesn't take into anything in the other numbers into account. And I'm going to say aside from counting the total number of values. And what I mean by that is we can talk about the median and it doesn't really, nothing else figures into that calculation besides that number, except for the fact that you have to at least have all the numbers and you have to use them to find the median. But it does, the other numbers don't really affect the outcome other than finding the one in the middle, okay? Is the median affected by outliers? No. The median is not affected by outliers. That's something that is nice and a good reason to use the median because sometimes these outliers are outliers because of bad reasons. So when there are outliers, That's one of the advantages of when you would want to use it. It's when they're outliers, and it may be more representative of the mean or the average. This is saying than the mean. Okay. And we're going to see some examples with that in a minute. But if you've got an outlier that's way outside of what is normal, you don't really want to count that because it's going to really throw your data off, like that person who made the $10 million for the basketball playing in the NBA, because the real average probably was 0, right? The mode is the one that is the most frequent value. This is not as common, it's just sometimes used. Most of the time, the mode really doesn't mean a lot. Does it always exist? Well, maybe, because there could be no mode, or there could be more than one mode. Okay. Do you take every value into account? No, right? You only list the ones that are listed the most. It's not affected by outliers. A lot of times when you were really using it is when it's most affected by or most appropriate. I don't know why that's not right in here. With qualitative data. What's the difference between qualitative data is an answer that is a word, like what is your favorite color? What kind of shoes do you like best? So when you can't, and we can't really calculate the mean or the median of those things that are qualitative, but we could get the mode, right? If most people check Nike as their favorite shoe, then we would be able to say, well, that's the mode of this. So it's most appropriate when we've got qualitative data. Okay, so here's our first example. A track coach wants to determine an appropriate heart rate for athletes during their workouts. She chooses 5 of her best runners and asks them to wear heart rate monitors during a workout. In the middle of the workout, she reads the following heart rates for the 5 athletes: 130, 135, 140, 325, and we're missing one, right? She's got 5 athletes. Or does it say 4? Sorry. No, she chooses 5. Okay, and it says, which is the better measure of average in this case? I don't know that it matters a lot, but I'm going to look and see if the other number is in the book, because they only gave us 4 heart rates, and there's 5 runners. So let's look real quick. Do you guys see anything odd there? Yeah, that 325 is probably, not probably, it is an outlier. And it's such a bad outlier that there might actually be a mistake, right? And you've gone to the doctor's office before. The other number is 145. You've gone to the doctor's office before, and they were probably like, they take your blood pressure twice a lot of times, because the first reading might be off because you might be nervous or something like that, right? So they want to make sure that whatever is coming up on that blood pressure machine is not an outlier. It's not way off. Okay, this 325, if this is really what happens, this person probably would be in cardiac arrest. That's not normal. So the question is, which is better measure for average in this case? Would we want to do the mean or the median, and why? What do you guys think? Sir? Like if we want to do mean or median, which is going to be the best representation of this data as to what's really going on with the heart rates in her team? Okay, well, if we do the mean, okay, we would add all of them up. So 130, just a little bit. So we got 130 plus 135 plus 140 plus 325 plus the one that was missing, which was 145, and that would be divided by 5. Okay. So that's 875. And when you're doing your project, this is going to be some of the things that it's going to ask you to analyze about your project is which measure of central tendency did you use, or which one did you think would be the best and why? Okay, so if we do mean, we are getting 175. When we look at the median, if I'd have to put them all in order, so 130, 135, 140, 145, and 325. Looks like the median, the one in the middle, is going to be 140. So which better represents this set of numbers right here? The 140 or the 175? 140, right? Yeah, because 175, there are 4 of those numbers that are lower than 175, right? So that number is it would be an overestimate. So we have to take into account that this 325 is probably an accident. So we really want to use the median. And the reason we want to give is 4 of the 5 values are fairly close together and seem reasonable for the mid-workout heart rates. The high value of 325 is an outlier. It's probably a mistake. So we've got 4 values that are pretty normal. We've got 1 value that is an outlier, so much though that we think it's probably a mistake. I mean, it would kill the person if they had a heart rate of 325. Okay, so if we use the mean, it includes the outlier, and we don't want that because we think it's a mistake. So we don't want to use that. So we want to use the median because it would not include the outlier. That would be the correct choice. If I want to describe this data, I would want to use the median because it doesn't include that crazy number. Okay. Look at the second one. A newspaper surveys wages for assembly workers in regional high-tech companies and reports an average of $22 per hour. Okay, the workers at one large firm immediately request a pay raise, claiming that they work as hard as the employees at other companies, but their average wage is only $19. The management rejects their request, telling them they are overpaid because their average wage is in fact $23. Can both sides be right? Okay, well, surprisingly, both sides can be right if they are using different definitions of average. In this case, the workers may be using the median while management uses the mean. For example, imagine that there are only 5 workers at the firm and their wages are, so they say, okay, so this is our scenario. If their wages are 19, 19, 19, 19, and 39. Okay, well, their median is 19. You agree with that? If I were to calculate their mean, it's probably 23, because what's happening, this 39 is pushing the average up. If these are your test scores, right, that 39 is going to make your average higher. So yeah, they can both be using, if they can both be using proper data depending on how they're saying what they mean. Is it fair to calculate this person? I would argue that you can't include the $39 an hour person in our calculation, right? Because they obviously are some kind of management or something. They're making double what we make. So no, I'm not going for that. Okay, so our average is really 19. This other company's is 22. We need a raise. So it just depends on how you look at it. All 100 first-year students at a small college take 3 courses in the core studies program. 2 courses are taught in large lectures with only 100 students in a class. The third lecture is taught in 10 classes of 10 students. Students and administrators get into an argument about whether classes are too large. The students claim that the mean size of their core studies classes is 70, and the administrators claim that the size is 25 students. Can both sides be right? So here's what the students are going, well, when I go to class, one of my classes has 100 students in it, another class has 100 students, and then my third class only has 10 students, and that's 3 classes. So they're saying, well, if you do all that, then I've got an average of 70 people in my classes. The administration, so this is the student. The administration saying, hey, wait a minute. And this is like in the media, they get statistics wrong all the time because it depends on how you're looking at it. The administration says, well, what we really have going on here is we've got one class with 100. I'm focusing on this right here, 10 classes of 10 students each. And they've got 2 courses. They've got 2 courses that have 100 students each. So they said, well, what's really happening is we got a class that has 100, another class that has 100, and then we've got 10 classes that have 10 people in them. Okay, and I could list 10 plus 10 plus 10, right? Or I could just say 10 times 10. Y'all good with that? Okay, and then they're saying, well, if we divide that, that's really a total of 12 classes. These 2 plus 10 of these, if we divide that, well, that's 25. So there's only 25 students per class, right? So the student is making this specific to them, okay, right? The student is saying that their calculation is the class size what the student actually found is the class size per student. And what the administration found is the students per class. Sorry about my misspellings today. I'm pretty sure I know how to spell student, but you know, the students per class. Well, those things are 2 different things, right? But it's easy to get that wording confused. So they have an argument about it, but they're really talking about 2 different things. This is making it really specific to one student, and this is making it specific to the whole school. So they're like, you can't say that just because you're in the 2 that are 100 big. We have 10 that only have 10 classes or 10 people in them. So it just depends on how you're looking at the data, and you have to make that clear. Okay, when we start talking about, this says the number of modes. One simple way to describe the shape of a distribution is by its number of modes or its peaks. When you look at this, you can kind of see that it goes up and comes right back down, this would be described as having one mode. Okay, a single peaked unimodal distribution. Same thing here. We just have one peak. This has got two obvious peaks here, two single peaked unimodal distributions. If this was our case, we would end up only having one mode though, because this one would end up being whatever is here is listed the most. Sometimes they'll ask for a second mode on a problem. Okay. So this says, how many peaks would you expect for each of the following distributions and why? Make a rough sketch. And these are kind of like matching. So it says how hours spent watching football on TV in January for 1,000 randomly selected adults. So this would be our, this graph goes with A. How many modes? 2, right? And it says mode for casual fans and modes for big fans. And we've got TV watching time down here. Okay. So we've got two groups that we were talking about that had two different modes. The number of people that were with particular last digits of 0 through 9 in the social security number, which this is B down here. This has no mode because those, like it, if we had 10 people in this class and we ask them what their last digit of their social security number is, chances are they're going to be all different. If it's a small group like that, we might get some that are the same, but if we ask 100 people what the last digit of their social security number is, then we're all probably getting closer to having no mode because they're going to be spread out, right? Because everybody, it's random. It can be 0 through 9. Weekly sales through the year at a retail clothing store, which is this one. Okay, well, there's going to be spikes in the sales. They've got that spring sales, back to school shopping, and then holidays as times whenever it's going to have more modes, right? Because it could actually happen 3 times in the year. And the last one, heights of 1,000 randomly selected adult women. So that one goes with D. So this is actually probably has one mode. There's probably, if we got 100 women, there's probably a chance that we're going to have, I think the average height of a woman is around 5'5". I might be wrong about that, but that would be this, whatever this is. There'd be more people that were 5 feet 5 inches than anything else. So it would only have one mode. Okay. Y'all good? Okay. We talk about being symmetric. The distribution is symmetric if it is left half is a mirror image of its right half. So basically, if you can just divide it in half and it's the same on both sides. So these would all be examples of things that are perfectly symmetric. The left side matches the right side. Sometimes we have something called data that is skewed one way or another. Okay, so if your data is skewed left, to me, I always told my students, look at this. To me, that means this, it looks like it's loaded up on the right side. Do y'all agree? Like the right side has more stuff on it, but it's skewed left. So it's I always told people, think of it backwards, right? So if there's more stuff on the right side, it's going to be left skewed. If there's more stuff on the left side, it's going to be right skewed. Okay. This is one of those things where we probably have more information on this side and it's pushed farther this way. We have less information or more information on the lower end. It's pushed this way. Okay. So for each of the following, so they've got, we looked at pictures and talked about these definitions right here, but it says for each of the following situations, state whether you expect the distribution to be symmetric, left skewed, or right skewed, explain why. So A says heights of sample of 100 women. Expect that to be symmetric, left skewed or right skewed. Yeah, I mean, it's probably going to be even out. There's not going to be anything that's going to make it. If we've got 100 women, that's a good number. So even if we have somebody really tall or really short, chances are it's still going to be kind of spread even. Number of books read during the school year by fifth graders. Well, okay, so I guess that one, it could depend. But I guess what I would say is there a chance that there's some kind of reading during the summer? Probably not, but there might be a reading program during the school where the kids are expected to meet a goal, right? You got to read this many books. And so during the school year, I would think that the data is going to kind of look like this. We're not going to have, there's going to be a few students who don't do what they're supposed to, but more than likely they want a good grade. So they're going to tend to be more on this higher end of reading books, which this has got more data on the right. So it is left skewed. Okay. Speeds of cars on a road where a visible patrol car is using radar to detect speeders. So once you get the bright lights in your face, right, that there's a police car up there that might pull you over, then you're going to slow down. And so I would argue on this one that we're probably going to have a lot more down here in the, let's just put some numbers with this, like 30, 40, and let's say this up here is like 70. These numbers down here are going to be a lot more than this up here, right? You're going to see more people that are slowing down and traveling these lower speeds, and that would be right skewed because they don't want to get pulled over. So they're going to not travel fast. So we've got more people in this group. Okay, does that make sense? So I think that we've got variation here, and we've got one more example. So I think we're going to talk about that on Friday. In addition to the other thing that I'm going to do on Friday is I'm going to post a video on how to find mean, median, and mode on the TI-84 graphing calculator. And I will post that as soon as class is over with on Friday.